Okay, these are the notes for section 3.4, and section 3.4 is still going to talk about how you can find out what is happening to a function by looking at its derivatives. So what we already know so far is the first derivative tells us where we have a max and a min, and intervals of where that function is increasing and decreasing. Okay? The second derivative, which is what we're going to talk about today, tells us where we have what I will call a POI, or a point of inflection, and then intervals of concavity. So you have to make sure you know which derivative tells you what information. So a point of inflection, or I'll always say POI, is a point where the graph of a function changes concavity. Where y double prime, or the second derivative, changes signs will be a point of inflection. Concavity test, a graph will be concave up where the second derivative is positive, and concave down where the second derivative is negative. Okay, that's what this information tells you. So an example of something that's concave up, this is concave up. There's two ways you can remember it. Okay, anything that can hold water would be concave up. And I always remember concave up looks like a smiley face. When you're up, you smile. Okay, concave down will not hold water. Okay, or it kind of looks like a frown. So this is concave up, concave down. A point of inflection, if I have a graph, this is x cubed. Do you see that from about, from here, somewhere around here, we're not sure where, but this part of my graph is concave down. And then all of a sudden it changes to concave up. Okay, so this point right here where it changes concavity would be called the point of inflection. All right, if I have something that's always concave up like this does not have a point of inflection. And so this one that's always concave down would never have a point of inflection also. Okay, so that's what concavity talks about and what a point of inflection is. So we're going to do an example. Again, there's going to be lots of writing for this. But here are the steps. To find a POI in concavity, you're going to find the second derivative, or where the second derivative is undefined. Set it equal to 0 and solve, just like we have been. Do a sign chart for your second derivative where you have your pluses and minuses, and then you'll be able to tell where your POIs are at and where it's concave up and down. Then we have something called the second derivative test. I haven't included any examples in this part, but we're going to talk about that in class the following day. All right, so let's look at example 1. Given x cubed minus 12x minus 5, find the following. So I kind of know in my head a sketch of this graph. This is something cubed, so it's going to look something like that. Okay, so let's find, and it could actually, go like this. I don't know, it's something that looks something like this, x cubed. And we could graph it to see, but we're going to find this information without graphing it. First thing we're going to do is find max or min. So part A, I know I find maxes and mins by finding the first derivative and setting it equal to 0 and solve. So my first derivative would be 3x squared minus 12. When I set that equal to 0, I can factor out a 3. And then when I set each factor equal to 0, I'm not going to do anything with that 3 because 3 can't equal 0. So I know that x squared is 4, which means x is going to be plus and minus 2. So you need to make sure you include that plus and minus in front. Then I know I'm going to do a sign chart. I'm always going to label that sign chart because on the AP test they want to know what they are looking at, and sometimes it's the first derivative, sometimes it's the second derivative. And I'm going to do my sign chart just like I have been. I'm going to choose numbers to go into my derivative equation. Okay, so when you're doing sign charts, it's always going to go in either the first or second derivative depending on what you're wanting to find. So when I plug in a number to the left of -2, like -10, plug it in, I'm going to get a positive answer. When I plug a number in between -2 and 2, like 0, I'm going to get a negative answer. And a number to the right of 2, I'm going to get another positive answer. So I'm going to write my answer over here. F of x has a, let's do the mins first, a min When x equals, I know I have a min when my derivative, first derivative goes from negative to positive. So I have a minimum at x equals 2 because f prime of x went from, and if you just want to put negative to positive like that, then that's fine. F of x has a max. We know that we have a max when the first derivative goes from positive to negative. So positive to negative happened at x equals negative 2 because f prime of x went from positive to negative. Okay, so that's part A. Part B, I'm going to do this in a different color. Intervals of increasing, decreasing. Okay, so we're going to say f of x is increasing, and we know it's increasing when my first derivative is positive. So that's going to be from negative infinity to negative 2, and from 2 to infinity, because f prime of x was greater than 0 or positive. F of x is decreasing where my first derivative is negative. So that's going to be from negative 2 to 2 because f prime of x is less than 0 or is negative. So parts A and B is what we've been doing, nothing new. Okay, now we're going to do part C. Find the point of inflection. All right, so the point of inflection, I have to find the second derivative. So the second derivative, if this is my first, second derivative would be what? F double prime of x equals 6x. Set that equal to 0 and solve, and I get x is 0. Okay, I still do the same thing. I'm still going to do my sign chart. This time I'm going to label it second derivative. I'm going to put 0 on there. And this time when I choose my numbers, I'm going to plug it into my second derivative equation. So when I type in, or when I plug in a number to the left of 0, like negative 10, I'm going to get a negative answer. A number to the right of 0, I'm going to get a positive answer. So part C, f of x has a point of inflection, or POI, when x equals 0, because f double prime changes signs. It doesn't matter what it changes to, from positive, negative, or negative to positive, as long as it changes signs. Now, if I did my sign chart and it didn't change signs, like if I just had plus plus or minus minus, then I would say f of x has no POI. So that's part C. Part D says, write your intervals of concavity. So again, intervals of concavity, concave up and down, we find by using the second derivative. So I'm going to write f of x is concave up, and that's what I'll write each time. CC and then my up arrow. From 0 to infinity, because my second derivative is greater than 0 there. And f of x is concave down from negative infinity to 0, because my second derivative is less than 0. And when we're in class, we're going to go over this and we're going to look at the graph of this so that we can actually confirm that that's what we have. Okay, so I must have a relative min when x equals 2 and a relative max. So it must go something like this. This would be the relative max, this would be the relative min at 2 and negative 2. Okay, this is increasing, decreasing, increasing. This is concave down, concave up. So we're going to look at the graph together in class. So that's example 1. Example 2, we're going to do the same thing. Part A, find the max and min. So f prime of x is 2x. Set that equal to 0 and solve, and I'm going to get x is 0. I need to do my sign chart for that. Make sure you label your sign chart. When I plug in a number into my first derivative, to the left of 0, I'm going to get negative. To the right of 0, I'm going to get positive. So f of x is only going to have a min because I went from negative to positive. f of x has a min when x equals 0 because f prime of x went from negative to positive. So that's part A. Part B, I'm going to talk about increasing and decreasing. So f of x is decreasing where my first derivative is negative. So from negative infinity to 0, because my first derivative is less than 0 or negative, f of x is increasing, that's increasing by the way, from 0 to infinity because f prime of x is greater than 0. All that stuff is what we've been doing. Part C is the new part, and the point of inflection. Points of inflection are found by the second derivative. So I'm going to take the derivative of my first one. So the derivative of 2x is just 2. Now here's the deal. To find the point of inflection, I'm supposed to take my second derivative and set it equal to 0 and solve. Well, I can't do that because 2 can never equal 0. So what does that mean? That means that I must not have a point of inflection. So I would write f of x has no POI. And part D wants to know, is it intervals of concavity? So when you do not have a point of inflection, you can still say if it's concave up or down by looking at your second derivative. My second derivative was a positive 2. That means my second derivative is always positive. That means that f of x must always be concave up since it was a positive number from negative infinity to infinity. And that makes sense because we know what the graph of y equals x squared looks like. It's this parabola with the vertex 0, 0, which makes sense. I already said I had a min when x equals 0. Okay, it's decreasing from negative infinity to 0, increasing from 0 to infinity, and it's always concave up. Okay, example 3. Example 3, this time they just want me to determine the concavity. I don't have to find the max or the min or the intervals of increasing, decreasing. Okay, so I have to find, in order to find concavity, the second derivative. So the first derivative, derivative of 3 is just 0. Derivative of sine x is cosine x. Concavity, I need the second derivative, so y double prime, derivative of cosine is negative sine x. I'm supposed to set this equal to 0 and solve. So I can divide by negative and I get 0 equals sine x. So I'm wanting to know from 0 to 2 pi, and this time I can include 0 and 2 pi because they use the brackets. That means my endpoints are included. Where is sine 0? Well, we should know from our unit circle that sine is 0 at 0, pi, and 2 pi. Okay, so this is what's going to go on my sine chart. Okay, but I'm going to start at 0 because that's where it told me my interval begins, pi, and I'm going to end at 2 pi. Okay, so when I plug in a number between 0 and pi, like pi over 2, into my second derivative, negative sine x, okay, and I plug in pi over 2, I'm going to get a negative answer. When I plug a number between pi and 2 pi, I'm going to get a positive answer. That kind of makes sense because if you remember what negative sine looks like from 0 to 2 pi, negative sine means it looks like this. That's the graph of negative sine x. So it's negative from 0 to pi, positive from pi to 2 pi. All right, so determine the concavity. So I'm going to write y is concave down from 0 to pi because my second derivative is less than 0. Y is concave up from pi to 2 pi because my second derivative is positive or greater than 0. And that makes sense because if I look at the original graph of 3 plus sine x, okay, and this is 2 pi, I'm just going to sketch a quick graph. Here's what that graph looks like. Something like this. Okay, so it's concave down from 0 to pi and concave up from pi to 2 pi. Example 4. Determine the points of inflection. Discuss the concavity of the graph. All right, so I have to find the first derivative. First derivative would be 4x cubed minus 12x squared. I don't have to do anything with that first derivative because it didn't ask me anything about maxes and mins or intervals of increasing, decreasing. So now I'm going to go ahead and find the second derivative, which is 12x squared minus 24x. I'm going to set that equal to 0 and solve so I can factor out a 12x and get x minus 2. So when I set each of these equal to 0, I get x is 0 and x is 2. So I'm going to do my sign chart with my second derivative because I need to find points of inflection and concavity. So when I plug in these numbers, I'm plugging it into my second derivative. And when you plug in your numbers, you should get plus, minus, plus. And again, I know that they've always alternated, but they won't always alternate. So you always have to check it. So I can write f of x has a POI, point of inflection, when x equals 0 and x equals 2. And we know that because the second derivative changes signs there. So because f prime of x changes signs. Okay, now let's talk about the concavity. F of x is concave up, where my second derivative is positive. So from negative infinity to 0 and from 2 to infinity, because f prime of x is positive or greater than 0. F of x is concave down from 0 to 2 because f prime of x is less than 0. Okay, we have one more problem, example 5. Okay, I don't know what happened to this one. All right, so example 5. Now look at what they gave us. Let f prime of x, they already gave us the derivative. So find the following. Identify where the extrema of f occur. So I'm just going to have to set my derivative that they gave me equal to 0 and solve. So you have to be careful and look at what they gave you. I'm going to factor out a 4x squared, factor out a 4x squared, and I would get x minus 3. Set each one of those equal to 0, and I get x is 0 and x is 3. I'm going to put that on my sign chart, and I'm labeling it as my first derivative. Okay, when I plug in my numbers. Now on this one, when I plug in my numbers, 4x cubed, I'm plugging it into that first derivative. When I plug in negative 1, I'm going to get a negative number. When I plug in positive 1, I'm going to get a negative number. So there's a difference there. And when I plug in a positive 5, I'm going to get a positive number. Okay, so this is part A. F of x has I only have a min for this one because it went from negative to positive. Has a min when x is 3 because f prime of x went from negative to positive. Okay, part B, ask for the intervals of increasing, decreasing. F of x is decreasing. Now I can just write this as one interval. So I would write it's decreasing from negative infinity to 3 because my first derivative, f of x, is negative or less than 0. F of x is increasing from 3 to infinity because f prime of x is greater than 0. Part C. Find where the graph of f is concave up or down. So I need to find the second derivative. My second derivative would be 12x squared minus 24x. Set that equal to 0. I can factor out a 12x and I'd get x minus 2. Set each of those factors equal to 0 and I get x equals 0 and x equals 2. I need to put that on a sign chart. Make sure I label the sign chart. And now I'm going to plug in my numbers. When I plug in my numbers, I'm plugging my numbers into my second derivative now. I would get a positive, negative, positive. So they just want to know where it's concave up and down. So f of x is concave up from negative infinity to 0 and from 2 to infinity because f prime or f double prime is greater than 0. And then f of x is concave down from 0 to 2 because f double prime is less than 0. And then part D, we're going to do some of these together where we are sketching a possible graph for a function given all this information. All right, so that is it for section 3, what is that, 3-4?